All right, guys. What we're starting today is Chapter 2. Today is going to be the first day of Chapter 2. And what we're talking about today is transformations. The main thing we are talking about today are transformations of quadratic functions. Because in Chapter 1, we talked about quadratic or transformations, the moving of the functions up, down, left, or right. The main ones that we actually talked about were linear and absolute value. Quadratics didn't show up too much. There was a few here and there, but the main focus was on linear and absolute value. We didn't do a whole lot with quadratics. And the main reason is because, well, this first section of Chapter 2, we're actually going to delve into quadratics. Now, this here, g of x equals a parentheses x minus h squared plus k, is kind of our general form of the quadratic. But I want to change it just a little bit. b x minus h squared plus k. Because this here is going to be the general form. Because our a in front is really going to deal with vertical stretch or shrink and our reflection across the x-axis. Because if the number there is negative, or there's a negative sign in a spot, it's going to be a reflection across the x. If it's a whole number or fraction, it's going to be a vertical stretch or shrink. Again, the sign, if it's negative, is only dealing with the reflection. The number is dealing with the stretch or shrink. Our value of b, if it is negative, it's a reflection across the y. And it's dealing with horizontal stretch or shrink. And then again, anything inside the parentheses is going to be the opposite of what we think. Our h was the movement which directions? Left and right. And again, it's the opposite of what we think, because if it looks like it's being subtracted inside the parentheses, it's moving to the right. If it looks plus, we have plus that value, it's moving to the left. It's the opposite of what we think. And the last one, the one that was the kind of the nicer out of the group, was our k value. Because the k moved the function up or down, and it's exactly what it looked like, because if it's plus that value, it's moving it up that far. If it's minus that value, it's moving it down that amount. And that's what we're going to be looking at today. Questions on this so far? Now, the first two transformations we're going to look at is horizontal and vertical translation. So if it's inside the parentheses, whatever that value is going to move it to the left or right. And it's the opposite of what we think. Because if we have x minus 4, it's going to move it to the right 4. If it's x plus 4, it's going to move it to the left 4. Because whenever we have that inside parentheses, it's the opposite of what we think. And then if we have a value being added outside the parentheses, or to that x squared, it's moving it up or down. And the biggest thing with these transformations, it's going to help us with solving. It's going to help us give us an idea of what the graph should look like, how the function should behave. And we're not going to have to graph any of these here. So when we look at this first one here, we want to describe the transformation. And that's it. We're not going to have to graph it. We're mainly just describing the transformation of this function from the x squared. So we're looking to see here what is changing. And there are two parts. We have the plus 4 inside the parentheses, and we also have the minus 1 outside. So what's one of these transformations going to be? Yes. So, no. So, Logan, guys, so what were you going to say?
Oh, you said in the
parentheses.
Yeah, I think to the left. Yeah, like to the left. Or
yes.
Does it matter, like the sign, like the?
Because it's plus, it looks like it should go to the, but it's the opposite of what we think, so it's going to the
Left.
How far?
4.
And what else?
-1.
Down 1? Down 1, yes. The minus 1 would be down 1.
And that's out of it?
No, that's it.
So, okay, so let me get this straight.
Mm-hmm.
So, if those little That thing comes down, right?
Yes. And if we graphed it, because again, we don't have to graph it, what it's telling us is it's taking all the points of that graph and moving them left 4 and down 1. So the point here, 0, 0, is going to go left 4 and down 1. So here at the point 1, 1, it'll go left 4, 1, 2, 3, 4, and down 1. Here at negative 1, 1, it'll go left 1, 2, 3, 4, and down 1. And it'll give us an idea of what the graph is going to do. It's moving it left and down. Yeah. So I'm not going to make y'all graph any of these here. We just need to describe the transformation. Yeah. Questions on this here?
Wait, I have a question. Does it matter where the curve goes?
Here it's going to go up because the normal function, we didn't do anything with a reflection across the x. Reflection across the x-axis will go from up to down.
Yes, it doesn't have to cross the other one.
No, this is just the original function.
So cross.
Let's look at this next one here. We have g of x equals x minus 3 squared. So how would this one move? How far? Is there anything else being done to this function? No. Because if it had plus 2 on the outside, then yes, it would move up 2.
So what is that 2?
That's just square. It's telling us it's a quadratic. Any other questions on this here?
No. Okay, so we're not graphing it.
Nope. Describe the transformation.
Right here. Right, so down, right.
Yes, because we have 2. The minus 2 inside is going to tell us we're moving 2, but instead of 2 to the left, it's to the right. So right 2. And? Because the minus 2 outside the parentheses is exactly what we think it is. It's minus 2, down 2. Right 2 and down 2. Questions on this here? And again, one thing we can always refer back to is just the general form. Where are those numbers in location to this here? Because plus a number on the outside is moving up or down. Yes, or minus a number on the outside is moving up or down. If we're adding or subtracting a number from x inside, it's left or right. Because the plus 5 inside tells us that we're moving 5 and questions on this here? All right. So let's look at the next one here. So, guys, focus up. So the number inside the parentheses, so we have minus 1. So it tells us it's either moving left or right, but we're moving to the right because it's the opposite of what we think. How far? 1. And up 2, because since it has the plus 2, it's moving it up 2. Questions on this here? We're good? Yep. Because inside the parentheses moves us left or right. When we're adding or subtracting from x, outside the parentheses that's added or subtracted is moving up or down. Any other questions on these here? Let's look at the next type of transformations. A reflection across the x or reflection across the y. If we have a negative outside those parentheses, or we have a negative in front of x and there's no parentheses at all, it's across the x. It's going to be across the y if that negative is in front of the x and it's inside parentheses. If the negative is with x inside parentheses, then it's across the y. So if they're not there, or it's outside parentheses, then it's across the x. Yes. Because that's the origin. That's where all of the functions start. The parent functions always start at the origin, 0, 0. Because our transformations, the horizontal left to right, moves it away from there. The vertical moves it up or down away from there. Any other questions? Now the other one that we have is horizontal stretch or shrink. Now vertical stretch or shrink. So it's a vertical stretch or shrink if that number is being multiplied in front of the parentheses, or there's no parentheses at all. It's in front of the x. If it's in front of the x without parentheses, it's a vertical stretch or shrink. The main giveaway for horizontal is if it's inside parentheses. If it's inside the parentheses, then it's a horizontal stretch or shrink. Okay? Now again, with left and right, it's the opposite of what we think. With horizontal stretch and shrink, it's the opposite of what we think. Because normally, if the value was, say, 4, 4 is greater than 1, so we would think it's a what? Stretch, yes? But with horizontal, it's a shrink. It's going to be the opposite of what we think. So if we get, say, 1/2 inside the parentheses, it thinks it should be a shrink, but it's actually a stretch. Now let's actually start looking at some of these here, because I feel more of the time that we look at the examples, they start making a little more sense. Now we have two things going on here. We have the negative and we have the 1/2. Is it inside parentheses? No. Which means the negative is not going to be a reflection across the y-axis. It has to be across the what? X. Because if the negative in front of that x is not in parentheses, it's across the x. The negative here, where there's nothing in front of it, it's attached to that x, is going to be a reflection. That's purely what it's telling us. So that negative is telling us that this is a reflection across. And the two axes that it can reflect across is x or y. It's one or the other. We're not going to be dealing with too many where we reflect across the origin, but it could be both, as if there's a negative outside parentheses and inside. Yes?
So if it doesn't have parentheses around it,
It's not across the y. Because if it's inside parentheses, it's across the y-axis. Are there parentheses? No, so it can't be inside, it has to be outside. So that means this is across the x-axis. So really the giveaway is it in parentheses? Because if it's in parentheses, it's across the y. If it's inside parentheses, it's going to be across the y-axis. No parentheses, it can't reflect across the y-axis. And we have the 1/2, yes? Is it going to be horizontal or vertical? Because horizontal is where? Inside. Is it inside the parentheses? So it's vertical. If there's no parentheses and we have something being multiplied by the x, it's going to be vertical or reflection across the x. And this here would be a vertical what? Because the number is what? 1/2, yes? So it'd be a shrink. Because if the number or values between 0 and 1, it's a shrink. If it's greater than 1, it's a stretch. Now, if you put this on the homework, especially for vertical stretch or shrink, I'm going to count points off again. Because what are we actually shrinking it by? Vertical shrink of 1/2. Write that again. Vertical shrink of 1/2. When we talk about vertical stretch or shrink or horizontal stretch or shrink, we've got to put the amount that it was stretched or shrunk by. Focus in here. Questions on this here? Let's put those away. Let's look at the next one. Guys, here we have 2x squared plus 1. So we have two transformations, yes? What's the easier of the two to identify? Well, we have the 2 in the parentheses, yes? We also have what? The 1. Well, what's our plus 1 doing? Up 1. I mean, that's up, down, left, right. Those are the easier ones to name. So we've dealt with that one. Now we have the 2 inside the parentheses, yes? What would that be? It is inside the parentheses. So we do have 3 transformations. It's either reflection across the y, horizontal stretch and shrink, or left and right. Well, left and right, that number is being what? Added or subtracted to x? It'd be the horizontal stretch or shrink, yes? Now it looks like it should be a stretch, yes? But inside parentheses, is it always what we think? No, it's the opposite. So it looks like it should be a stretch, yes? So it's actually a shrink. Of, and it's not 2, 1/2. Because we flip it. Because if we think back to when we did horizontal stretch and shrink and we applied it, we had to flip the number when we plugged it in. We got to flip it back when it comes out of the function. Or we can put 1 over that amount. So 1 over. So one way we can use the calculators to see this, because with horizontal stretch and shrink, you can put 1 over whatever that amount is and see what we get. So if we put 1 over 2, well, we get 1/2. And that would be the shrink. Interestingly enough, after we write it, actually kind of looks like it should. Horizontal shrink of 1/2. But in the function, it is 2.
Why would you? Okay. How do we know that the 1 goes over 2?
Because we're flipping it, making it 1 over that value.
Okay, what do you mean by that?
So we make it as 1 over b, whatever number is in the place of b. Here, the number is, so it's 1 over 2. Or we can flip it, because the denominator for 2 is 1. So 2 over 1 becomes 1/2. Any other questions on this part here? And we know, so almost. So looking at this here, reflection across the x-axis is correct because we have this negative outside, this negative here, outside parentheses. We know it's outside, well, because there are no parentheses. And whenever we have a negative attached to the x, outside parentheses, there's going to be a reflection across the x-axis. Questions on how we figured out that it's a reflection across the x-axis? So that takes care of the negative. But we also have the 3, which is a vertical stretch or shrink, because it's outside the parentheses. If we had parentheses around it, it wouldn't be vertical, it would be horizontal. So this is vertical. Stretch or shrink? Stretch, yes. Of 3. Because when it's outside the parentheses is exactly what we think. Of 3. The negative is the reflection. The 3 is our stretch or shrink. The reflection's the only one we don't have to give a unit or amount for. We don't have to give it a unit or amount for reflections, but vertical stretch or shrink, horizontal stretch or shrink, moving it up, moving it down, moving it left or right, we have to have an amount for all of those there. Questions on this here? So again, we have 2 movements for this next one. The nicer of the 2 is the, well, the -2, I think. Because if we're subtracting 2 from the function, we're moving it which down. And the other movement is the 1/4 inside the parentheses, yes? Since it's being multiplied, and if I look at this kind of example I have on the board, it's in place of the B spot, yes? What is B? Horizontal stretch or shrink. So, and this is a horizontal, what? It looks like it should be a shrink, yes? But it is stretch, because it's always the opposite of what we think. Horizontal. So 1/4. Because it looks like, so 1/4, when we talked about vertical stretch or shrink, because if it's a shrink, the number's between 0 and. So 1/4 is between, so it looks like it should be a shrink. But again, anything inside those parentheses is the opposite of what we think. So it looks like a shrink, but it's actually a stretch of, we need our amount. So 1/4 becomes
4/1.
4/1. We flip it.
4.
Just 4. That's it. And really, this, everything we're going over today, the horizontal stretch or shrink and flipping that unit is the most challenging of this whole spot. Questions on this here? We ready for the next one? So this one here, we only have one transformation, which is the 1/3. Which transformation would that be? And again, if it's helpful to have the general form written down, write it down and match it up. As I see, okay, I've got something inside parentheses. You're looking at the bx minus h. Is that 1/3 being added or subtracted to x? Is there a plus or minus sign between x and it? No. So we know it can't be left or right. Left or right has to have addition or subtraction sign between x and that value. So left and right's gone. Is the 1/3 negative? No. So it's not a reflection across the y-axis, which really leaves me with stretch or shrink. It looks like it should be a shrink, but it's actually a stretch. Yes. Of. And really, once we flip it, it does match back up. Because 3 is greater than 1, so it is a stretch. So if that helps also, you take whatever that value is, flip it, and then line it up. So we take it from 1/3 becomes 3. 3 is a stretch. Questions on this here? Let's look at this next one here. So we do have two movements, yes? What's one of them? So we have the +3 and -1. Which one do you want to work with first? The -1 inside, yes? Which is moving where? Right? Because since it's inside, it's the opposite of what we think. So it would be right how far? Right 1, because -1 inside makes us think that it's going left, but it's actually going to the right. 1. And the 3 is in the place of A in the general form, yes? A is either vertical, stretch, or shrink, or reflection. The only time it's a reflection is if it is negative. Well, it's not negative, so that tells us it's a vertical stretch, yes, of vertical stretch of 3. That's it. Ready for the next one? I think this is the last one here. Yes? How many transformations do we have? Because we've got the +3 inside. We have the +2 on the outside, but we also have the negative. So we can start with up 2, yes. Up 2, the +2 on the outside tells us that it's moving up 2. It's exactly what we think. Then where can we go next? We can do the +3, because that's kind of nice. Because we're moving 3 units which way? Left. Since it's +3, opposite would move to the left, 3. And the negative would be a across the since it's outside parentheses, it's the x-axis. If it's inside the parentheses and connected with that x, it's across the y-axis. So for this assignment, problems 3, 4, 7 through 10, describe the transformation. You do not have to graph. Do not graph. 3, 4, 7 through 10, describe the transformation. You don't have to graph. 17 through 20, describe the transformation. You don't have to graph. 23 through 25, describe the transformation. You don't have to graph it. Do not graph it. So really, this entire assignment is just describing the transformation. You're just describing the transformation, and that's it. Yep.